Good morning, everyone, and welcome to the 4th Akira Suzuki Awards Ceremony. I'm Yu Harabuchi, the Fusion Research Coordinator of ICReDD, and I will be your MC today. To start the event, I'd like to ask the Chair of Akira Suzuki Award Organizing Committee, Professor Masaya Sawamura, to come to the stage to give opening remarks for Akira Suzuki Award.
On behalf of the organizing committee, I'd like to extend a warm welcome to everyone joining us from around the globe for the 4th Akira Suzuki Awards Ceremony. I'm very honored to chair this ceremony. We are extremely excited to have established this award, and on behalf of everyone at ICReDD, I'd like to thank all of you for being here to help us celebrate this momentous occasion and to honor two prominent scientists in the field of chemical reaction design and discovery. I'm glad to have so many of you joining us both in person and virtually for this event, and I'm very much looking forward to the lectures from our two award winners. We thank everyone for participating in the award ceremony and lectures hosted jointly with the 8th ICReDD International Symposium. We have nearly 300 participants, while a majority are from Japan. We have many participants from university, research institute, and industry around the world. Thank you so much for your participation. This award and award ceremony are financially supported by the TOSO Corporation, in cooperation with ICReDD. I would like to thank the administrative staff of ICReDD for all the behind-the-scenes work they put in to make this event possible. And I would like to especially acknowledge the Research Administrative Director, Professor Yasunori Yamamoto. Please join me in thanking Professor Yamamoto. Thank you very much. In addition, special thanks are given to Hokkaito University, especially the Public Relations Divisions, Department of Public Engagement of Hokkaito University, for announcing the award in various media. The TOSO Corporation is a leading company that uses cross-coupling reaction to produce electronic materials such as the liquid crystals and organic ELs, as well as semiconductor materials such as resistor monomers. Professor Suzuki acted as a technical advisor to the TOSO Corporation for over 10 years. In addition to providing research and development guidance, Professor Suzuki contributed to the TOSO Corporation's information dissemination activities. The Institute for Chemical Reaction Design and Discovery, ICReDD, was established in October 2018 as one of the 18 institutions of WPI. WPI is an abbreviation for the World Premier International Research Center Initiative, which was created by the Ministry of Education, Culture, Sports, Science, and Technology in order to create world-class research centers with a core of high-level researchers. The ICReDD slogan, "Revolutionize chemical reaction design and discovery," express our vision to renew the way chemical reactions are developed by fusing computational science, information science, and experimental science. Professor Akira Suzuki, University Professor and Professor Emeritus of Hokkaito University, was awarded the 2010 Nobel Prize in Chemistry for his research on cross-coupling reactions of organoboron compounds, which is known as Suzuki coupling. The Suzuki coupling reaction has made a significant contribution to the development and mass production of products that are familiar to us, such as pharmaceuticals, peptides, liquid crystals, essential for IT equipment, and organic light-emitting diodes. And now I am extremely honored to introduce you our special guest. Today, we have the privilege of being in the presence of a great hero in the field of chemistry. Please join me in giving a warm welcome to Hokkaito University Professor and Professor Emeritus Akira Suzuki.
Thank you very much, everybody. I'm very happy to attend this meeting today. So
先生、ちょっとオーディエンスの方で。
recently, I have already the 94 years old, so old person. So it is not so often to attend this kind of academic meeting, but today, especially, I am very happy to have this meeting here in our university, Hokkaito University. Thank you very much again. Thank you.
Suzuki Sensei, thank you very much for attendance today and with warm words. It is truly an honor for all of us to have you here. Thank you very much. Please continue and continue to enjoy the ceremony and the lectures today. Let's return to the introduction of the Akira Suzuki Award. The Akira Suzuki Awards were established in 2021 by the Akira Suzuki Award Organizing Committee in commemoration of Professor Akira Suzuki being awarded the 2010 Nobel Prize in Chemistry and to celebrate his 19th birthday. The purpose of the award is to recognize outstanding contribution to research in the discovery of chemical reactions and to contribute to the advancement of science and technology. The two awards, the Akira Suzuki Award and the ICReDD Award, are bestowed upon researchers who has made outstanding accomplishment in the development of chemical reactions in the field of experimental chemistry or in the field of computational or theoretical chemistry and information science. The Akira Suzuki Award is for the field of experimental chemistry, and the ICReDD Award is for the field of computational and theoretical chemistry and information science. Each award is given to one person each year, regardless of age or nationality. Each award winner receives a specially designed medal, very nice medal, and a momentary prize of $10,000. The award organizing committee is comprised of 6 professors from Hokkaito University. I have had the honor of serving as the chair of this committee, and Professor Tetsuya Taketsugu here is the vice chair. The Akira Suzuki Award winner is determined via the nomination and the selection process carried out by committee consisting of top experimental chemists from Hokkaito University and around the world, as shown here. The ICReDD Awards winner is similarly determined by a committee consisting of top theoretical chemists and information scientists from university in Japan and abroad. I would like to thank all the members of these committees for their generous support. Thank you very much. I will now commence with the formal presentation of the Akira Suzuki Award. Now, To start, I'd like to briefly recognize the past winners of the Akira Suzuki Award. Professor Stefan Buchbald of Massachusetts Institute of Technology in 2021, Professor John Hartwig of the University California, Berkeley in 2022, and Professor Eric Carrera of Swiss Federal Institute of Technology in Zurich. Now, joining this list of prestigious winners, I am very, very happy to announce the winner of the 4th Akira Suzuki Award for outstanding accomplishment in the field of experimental chemistry. The Akira Suzuki Award winner is Gregory Fu, Norman Chandra Professor of Chemistry at California Institute of Technology. Congratulations. Conventional cross-coupling reactions make use of aryl bromide or iodide for efficient sp2-sp2 carbon bond formation. However, these traditional methods are less efficient when applied to aryl chloride and more difficult with alkyl electrophiles, which undergo problematic side reactions such as beta hydride elimination. Professor Fu introduced numbers of very important concepts that address these issues, making tremendous contribution to the advance of cross-coupling chemistry, organometallic chemistry, and organic synthesis. Professor Fu's novel catalytic system based on palladium, nickel, and copper complexes enabled selective and very efficient formation of carbon-carbon and carbon heteroatom bonds with a wide range of aryl chloride and alkyl electrophiles. He has further advanced these methods for achieving enantioconvergent cross-coupling reactions of racemic electrophiles. Namely, Professor Fu's research achievement not only expanded the scope and utility of cross-coupling chemistry, but also represented a conceptual breakthrough in asymmetric synthesis. Professor Greg Fu received a BS degree in 1985 from MIT, where he worked in the laboratory of Professor Barry Sharpless. After earning a PhD from Harvard in 1991, under the guidance of Professor David Evans, Professor Fu spent 2 years as a postdoctoral fellow with Robert Graves at Caltech. In 1993, he returned to MIT, where he served as a member of faculty from 1993 to 2012. In 2012, he was appointed the Alta Professor of Chemistry at Caltech. Professor Fu is currently the Norman Chandra Professor of Chemistry at Caltech. Professor Fu received the Corey Award of the American Chemical Society in 2004, the Mukayama Award of the Society of Synthetic Organic Chemistry of Japan in 2006, the Award for Creative Work in Synthetic Organic Chemistry of ACS in 2012, the H.C. Brown Award of the ACS in 2018, and the Nobel Prize of Society of Synthetic Organic Chemistry Japan in 2022. And he is a member of the American Academy of Art and Science and of the National Academy of Science. Now, we will confer the award. Professor Fu, please come up on the stage to receive the Akira Suzuki Award.
Professor Fu, the winner of Akira Suzuki Award, will receive a medal and a monetary prize of $10,000 US. Professor Fu, now we would like to ask you to share a few words on the occasion of receiving the Akira Suzuki Award.
Again, of course, it's a tremendous honor to receive this award that recognizes the achievements of Professor Suzuki, one of my heroes in chemistry. And as was mentioned before, another dimension of this chemistry that's very humbling to me is to join this list of previous recipients who were my friends, colleagues, and such. So it's interesting, the very first time that I came to Sapporo was actually for what was then called the Nozaki Conference for young faculty members. And in fact, unfortunately, that conference is no longer existent. And Eric and I and John and I, who were at that conference, are no longer young, but that was a very enjoyable first visit to Japan as a scientist. So we all know that Professor Suzuki won the Nobel Prize in Chemistry in 2010 for his tremendous contributions to synthetic organic chemistry. But I think it's fair to say that not all Nobel Prizes are actually equal. And I think if you sort of look at the impact that the Suzuki-Miyaura reaction has had on synthetic organic chemistry, it's really tremendous. So obviously synthetic chemists have been exploring for centuries the development of new reactions. And in this study, there was an analysis of present and past synthetic methods used in medicinal chemistry. And in terms of the occurrence of these various transformations, again, for all of the reactions that have been discovered in the history of organic chemistry, the Suzuki reaction came in second in this ranking. And what's also sort of noteworthy is the fact that, as we know as synthetic chemists, carbon-carbon bond formations are central to the synthesis of organic molecules, and this was the only method focused on carbon-carbon bond formation that has actually made the top handful of reactions. So my program has been very heavily impacted by the pioneering work of Professor Suzuki. So over 20 papers from my laboratory during my career have focused on further developments of the Suzuki reaction. And interestingly, if you actually look for citation data on our chemistry, our two most cited non-review papers are all focused on second-generation methods for Suzuki-type coupling reactions. So again, his work has really had a profound impact on my research program over the years. So I have been very fortunate over the years to intersect with Professor Suzuki. So he's been an inspiration not only scientifically, but also as a person. So one example was at the International Symposium on cross-coupling in organometallics that was held in Lyon in 2007. And you'll notice that in this picture, in addition to Professor Suzuki, obviously an absolute leader in the area of cross-coupling, two other giants in this field, Professor Tamao and Professor Hiyama, were also present. And actually, right above Professor Suzuki is a picture of Victor Grignard, another Nobel laureate in chemistry, who spent considerable time in Lyon. A second time that we had the pleasure of intersecting was actually at the Nobel Prize celebration in Stockholm in 2010. It was a real joy to participate in that celebration of Professor Suzuki's incredible contributions to synthetic organic chemistry. So again, I'd like to acknowledge and thank Professor Suzuki for his science and for his inspiration on a personal level over the past 20 or 30 years. I'd like to acknowledge my coworkers. It's their work, obviously, that's being recognized by this award. They did all of the chemistry that we've described during my career. I'd like to acknowledge the selection committee for the Suzuki Award for being chosen for this really tremendous honor, ICReDD and TOSA, not only for their administrative support, but also their financial support. And then, of course, the faculty here at Hokkaito University for organizing the symposium and being such warm hosts. Thank you.
Thank you for the speech, and congratulations once again, Professor Fu. Thank you very much, Professor Samura, for presenting the award. Next, I'd like to ask the Vice Chair of Akira Suzuki Award Organizing Committee, Professor Tetsuya Taketsugu of ICReDD, to come to the stage to present the ICReDD Award.
Thank you very much, Harabuchi-san. So now I would like to begin the presentation of this year's ICReDD Award. Firstly, I would like to introduce the past recipients of this award. Professor David Wells of University of Cambridge in 2021. Professor Kendall M. Houck of University of California, Los Angeles in 2022. And Professor Frank Nies of Max Planck Institute for Coal Research in 2023. And it is now my great honor to announce the winner of the fourth ICReDD Award, recognizing outstanding accomplishment in the fields of computational or theoretical chemistry and information science. The fourth ICReDD Award winner is Professor Alán Aspuru-Guzik, Professor of Chemistry and Computer Science, University of Toronto. Congratulations. Professor Alán Aspuru-Guzik conducts groundbreaking research at the intersection of quantum information, machine learning, and chemistry. He was a pioneer in developing algorithms and experimental implementations of quantum computers and quantum simulators, specifically dedicated to chemical systems. His work includes studying the role of quantum coherence in excitonic energy transfer within photosynthetic complexes. And he has significantly accelerated discovery by calculating organic semiconductors, organic photovoltaics, organic batteries, and organic light emitting diodes. Additionally, Professor Aspuru-Guzik has made notable contributions to the development of molecular representations and generative models for the automatic learning of molecular properties. Currently, he is interested in automation and autonomous chemical laboratories for accelerating scientific discovery. Professor Alán Aspuru-Guzik received his Bachelor of Science from the National Autonomous University of Mexico in 1999, and his PhD from the University of California, Berkeley, in 2004, where he also completed a postdoctoral fellowship from 2005 to 2006. He began his independent career at Harvard University in 2006 and became a full professor there from 2013 to 2018. Since 2018, he has been a professor of chemistry and computer science at the University of Toronto. Among other recognitions, he was awarded the Sloan Research Fellowship 2009 and the Camille and Henry Dreyfus Teacher Scholar Award 2009. He was named one of the best innovators under the age of 35 by the MIT Technology Review 2010 and received the Early Career Award in Theoretical Chemistry from the American Chemical Society 2013 and the Google Focus Award for Quantum Computing 2018. He is an elected fellow of both the American Physical Society and the American Association for the Advancement of Science. And he received the Early Career Award in Theoretical Chemistry from the American Chemical Society. And in 2024, Alán was named one of the top 100 most powerful Canadians by McLaren's magazine in the AI category.
Now we will confer the award. Professor Aspuru-Guzik, please come up on stage to receive the ICReDD Award. Professor Aspuru-Guzik, the winner of ICReDD Award, will receive a medal and monetary prize of $10,000. Professor Aspuru-Guzik, we would like to ask you to share a few words on the occasion of receiving the ICReDD Award.
Okay, I didn't bring slides, so I'm gonna wing it, okay? So it's really an honor to be here and receive this ICReDD Award. Not only because I'm, of course, in front of Professor Suzuki, Professor Fu, the recipients of the Experimental Award. So I'm very happy to receive the Computational and Information Science Award, which I think is fitting. I think I'm one of the only few professors of chemistry and computer science. I think about half of my group does computer science. And I think it's connected also to the Nobel Prizes. This year there were 2 Nobel Prizes for AI, as you know, one in chemistry and one in computer science. When I was at Harvard around 2012 and I was searching for organic light emitting diodes, that's why I was very happy to see that Professor Suzuki was working on organic light emitting diodes with TOSO. So a professor came to Harvard called Ryan Adams, and he came there from Toronto, okay? He came from Toronto from the group of Professor Jeff Hinton, which received the Nobel Prize in Physics this year. And Ryan Adams and I collaborated and we did the first molecular representations for deep learning. That is now my second most cited paper. It turns out to be a paper published in the journal NeurIPS, which is the computer science equivalent of JAX, let's say. And basically from there was a cascade of developments that led to the first AI drug discovered molecule in 2019. Together with In Silico Medicine, we did that, the first AI drug discovered lead molecule as a lead candidate for drug discovery. I won't talk to you about those early AI discoveries, but I'm going to talk to you today about another intersection of AI with chemistry, which is the idea of robotics and automation. So I would like to say that I'm glad that there is a prize for the intersection of information science and chemistry, because information science and AI and machine learning, together with automation, I think will be changing all fields, including our field. And there is a growing cohort of people that are interested in this kind of new subfield of chemistry, right? Which I like to call accelerated chemistry. So it's an honor to be here in front of everybody, and I will later tell you about my research on this area. I want to thank the committee for selecting me and everybody here for everything. Thank you very much.
Thank you for the speech, and congratulations once again, Professor Aspuru-Guzik. Thank you very much, Professor Taketsugu, for presenting the award.